Hey guys, how you doing? Josh here, aka Super Software, coming at you guys with another custom Android View tutorial / example. In this video, we're going to be covering how to draw on a canvas in a custom Android View, and for the specific example, we're going to be doing a custom graph. So we're going to be drawing a lot of data points on the screen on a custom Android View canvas. If you guys want to see the Medium article, which is a very quick explanation, probably about between 15 and 10-minute read on how to do this, and you guys can copy and paste code, please see the description below. Also, if you would like to see the GitHub code for this sample project, please see the description below as well, and I will post the link to the GitHub repository that this lives in. So you can see we got the emulator on the right hand side of the screen and Android Studio on the left. Currently, if we run this application, while this is running, I'll just give a little bit of disclaimer. I'm doing this tutorial live and I don't have any documentation in front of me, so I apologize if I stumble or if I get stuck up on anything, but this is all real development. So in the Android example graph view application, we have a hello world text view. Let's jump into the activity main here. You can see that we have a coordinator layout with a text view. Let's get started with creating our custom Android view. So first, with any custom view, you need to create a new class, and we're going to call it we'll call it graph view. Yeah, we'll call it graph view. Now, with any custom view, you're going to want to construct it with two things. First, you're going to want to construct it with a context as well as an attribute set. Now, the context is required for any view construction, whether it's in Java or Kotlin or XML. Now, when you're constructing it in XML, you're going to want to also implement the attribute set, because if you're constructing your view in XML, you're going to be at least at a minimum supplying the width and height of the view, which is either wrap content or match parent, or you're going to be supplying some kind of DP value. And if you're doing it in XML, you need to supply the attribute set, because that's what's going to be giving you the attribute set for your view. And we're just going to be we're going to be extending the Android class view. We're not going to be getting any fancy. We're not going to be getting fancy with it. We're just going to be doing default view, and we're going to pass in the context and attribute set. So if we look at the constructor method for an Android view, the minimum you can take is a context. You can also pass an attribute set, but you can also pass in a defined style attribute and a file style resource. But we don't need those two. We're just going to be starting with these two for now. Cool. So with that being said, what does a graph use? So in real life terms, a graph uses an XY pair as a plot point. You know, if you're drawing a graph in math class, you need an X and a Y value. So let's create a data class called data points. Okay. And this data point is going to be having an X value, which we'll call it an integer for now. It might change later. I don't know yet. And a Y value, which is also an integer. And like I said, this could change later, but for now, let's just call it that. Now, for all of you Java developers who are not familiar with Kotlin, a data class is just an easy way to create a class with not a lot of boilerplate, and a data class already implements things for you like equals and toString and hash. So a data class is just an easy way to create a class that just holds values for you. So don't worry about that. Now, another thing that we need to do is we need a way for our graph to hold these values. So we're going to say private val data set is equal to a mutable list of data point. That's the wrong one, data point. So this just creates an empty mutable list of type data point. We're going to want a method to set data on this view. And to set that data, we're going to want to pass in a new data set of type list of type data point. So we're going to pass in a list of data points, and we're going to say data set clear dataset add all new dataset. That might be a little bit confusing, but basically we're going to take the current dataset, we're going to take everything out of it because we're setting a new dataset on it, and then we're going to add all the new data points to that empty set. So now that we have a way to set the data points, we're going to actually want to set up this view. So currently our activity has a text view. We're going to replace this with a graph view, which is, you can see the namespace supersoftware.androidexamplegraphview.graphview. So you can see that now that we've created a custom view which extends the Android view, you can actually get this for free in your XML and implement it in your XML. So the width is going to be match parent, the height is going to be match parent. We're going to give this an ID so that we can add data to it. We're going to call it graph_view. Super simple, right? Let's exit out of our XML. We're not going to need that anymore. And in our main activity, we're going to say GraphView.setData. Let's rename this. I just named it set. I really meant to say set data. And we're going to do the refactor. So we have set data. This is expecting a list. Let's pass in a list of, which is the same thing as empty list for now. Let's create a private function to create a random data set for us. So generate random data points. Generate random data points. Now, in a real production level application, you're not going to have something like this. You're going to have something coming back from a server or from a database that has a list of data points or a list of something, list of data transfer objects. They're going to have some kind of plotting values that you're going to use to plot them on the screen. But for now, we don't have anything that's giving us data, so we're going to generate some random data for ourselves. This is going to return a list of data points, and we're going to do a for loop from 0 to 20. We're going to do for each from 0 to 20. We're going to do a map from 0 to 20 so we're going to take the 0 to 20 value. We're going to create a data point from it, which is the integer value from 0 to 20. And then we're also going to take, we're going to create, before the loop, we're going to create a random object. And we're going to create this before the loop so that it's not created every time in the loop, because we don't need it to be random every time in the loop. We just want, so I apologize. We want the value to be random every time in the loop, but we don't need to create a new random object just to get a random value every time in the loop. So we want a random y value in the loop, and we're going to say random dot next integer, and you can see that this takes a bound. So if we gave this 100 or something like 50, we're going to create an integer from 0 to 49. So if we do a +1 here, there should be an integer that's created from 1 to 50. So with that being said, we are now creating a data point for every integer between 0 and 20, and then a random y value from 1 to 50. So if we return this map, excuse my typing, we now have a function that generates us random data points from x values from 0 to 20 and y values from 1 to 50. So we can now call, instead of empty list, generate random data points. So every time this activity is created, we are calling GraphView set data with random data points. So inside the GraphView, we're saying set data, clear, add all new data set. This all looks great, right? Well, we need a way to draw these data points on the screen. Every view has a method called onDraw. This does not need to be nullable. Kotlin says it should be, but it's not, because onDraw provides you a canvas. A canvas in Android is what every view uses to draw things on the screen for you. Every view under the hood, whether it's an edit text or a button or something else, draws things on the canvas. So we need a way to take this data set and draw it on the screen, or draw it on the canvas. Okay. Let's start real simple, and let's just draw a circle for every data point. To do that, to draw something, we need a paint object. So we're going to make a variable called, or a value called data point paint. And we're going to create a paint object from Android graphics package. And on that, we're going to do an apply. And we're going to say color is equal to color.blue. Okay. Also, with that paint object, in onDraw, we're going to call dataset.for each object, we're going to do canvas.drawCircle dataset. So this for each is a data point. We can name it. We don't have to name it, but we're gonna name it to be a little bit more clear. We're gonna do data point dot x data point dot xval. So we want to go back and say xval. And the radius of this circle should be something maybe like 10f, and paint is going to be data point paint. Now you can change this 10f to be smaller or larger, depending on if you want your circle to be thinner or thicker. One thing we have to note here is that we have integer values for our data point, for our x and y values. So we have whole round numbers. This draw circle wants a float value from 0 to the width of the canvas. And same thing with the y, from the 0 to the height of the canvas. But we're supplying it with a random x value and a random y value. We don't know what it's going to be in this view. We just know that it's a integer value. But the point being is that we need to do some math on this view, because if you have the maximum y value, maximum x value being 50 and the minimum x value being 0, the width of your screen on your canvas is going to be between 0 and 50. But there's no way for you to know that on your canvas. So we need to do some relational math, because the width of your canvas, let's say that it's 1500 pixels wide, you need to be able to relate 50 with your maximum x value with the number 1500 as a pixel value. So to do that, we're going to need to do a little bit of math. First of all, when we set the data, we're going to need to say, so let's save off a couple of member variables here. So we're going to need private var, because this is going to be a changing value. X min is going to be equal to 0. And we're going to need a couple of them here. So we're going to need x max, and we're going to need y min and y max. Okay, so they're all going to start off as 0. And when we set the data, we're going to say x min is going to equal new data set dot min by it dot xval dot xval. And if there is no minimum value, which means the list is empty, we're just going to say, okay, we'll set it to 0. Because if it's an empty list, we don't really care. Okay, so we also have an x max that we're going to say max by it.xval else 0, because we don't care if it's an empty list. We're going to duplicate this and say y min and y max are equal to min and max by y val. Okay, else 0. So when we set the data set, we want to set the window to be equal to the min and max values for x and y, so that the window is set up to show all the data points in the data point set. Now you can set these x mins and x maxes and x y mins and y maxes to whatever you want, and maybe you can have like some kind of toggle in your application to change that value, or if you guys want to do like a pinch to zoom kind of thing, you're going to be changing what these are. But for this example, we're going to be keeping it simple, and we're just going to set the min and max values to what the min and max values are in the data set, so that everything fits into the one window. So now that we have those, we're going to need to map those data points, the x and y val integers, to some kind of pixel value based on how wide and tall the screen are. How wide and tall the screen is, sorry. So we're going to say val real x is going to equal the width of the screen, or rather here, this needs to be in the for each, because it's going to be changing for every data point. So the real x is going to equal data point dot xval divided by the width of the view multiplied by, so let's think about this. So the xval, so look, if this was 50 and the screen width was 1500, we would get a percentage value, and we would need to multiply this. Let's see, this should be x maximum. So when we take an x point, so let's say this was 25 and the x max was 50, that means we're going to get a floating point value, and actually we're doing integer division right now, so we need to do 2 float on this first value. So now we're going to be doing division on a floating point value of 25 divided by 50 would give us something like 0.5. But plotting something on the canvas at 0.5 doesn't mean anything to the canvas. So we need to multiply this by the width of the view to get where the actual x point should be plotted. So if the width of the screen is 2000 pixels, and we're saying that this x point should be plotted at 0.5f because it's halfway to the maximum value, we're saying that this overall real x value should be 1000. So let's duplicate this, and let's say real y is equal to data point dot y value divided by y max, and this time we're going to multiply by the height. This should give us the real x and the real y of where we're going to be plotting on the canvas based on the x and y value of the data point compared to the floating value of the canvas. So now, instead of these data point.xvals, we're going to say real x, and real y. Let's run this on the application and see what we get. It's going to take a second to compile. Okay. And you can see that we have data points showing on screen. Now, one thing that we have not done on set data, and that's kind of important, it just doesn't really seem like it, is that when we set the data, we want to invalidate the view. And what invalidating the view does is it requests the layout of the view, which means that the view is going to be redrawn, which means onDraw is going to be called. So basically, when you invalidate, onDraw is going to be called. So when you set new data, you're going to want to redraw your view. Now, the reason why this works out for us is because it's kind of a race condition at this point. It means on the system I'm running, it's fast enough to the point where I'm able to set the data on the view before it's even drawn. In a lot of cases, your system or your device is not going to be fast enough, and with the current code, without invalidate, you're going to be drawing the view and then setting the data on it, and the view will not be redrawn. So we're going to want to make sure we have invalidate in there. We're just going to run that again. It should not look any different other than having new random data. So you can see that we have random data being plotted on the screen. That's all cool, but this doesn't really look like anything, right? So let's make this look a little bit more like a graph, right? So let's do a canvas.draw line. Start x is going to be 0f, start y 0f. We want to start in the top left corner, and we want to stop in the bottom left corner. Sorry, we want to start in the top left corner. We want to end in the bottom left corner. So the stop x is going to be also 0f. The stop y is going to be height of the view to float. And as you can see, we need another paint object. So we're going to call this private val axis line paint is equal to paint object, construct a new paint object, dot apply, where the color is equal to color. We'll make the axis color something a little bit different so we can see it, and we'll call it color.red. and the stroke width of this axis line paint is going to be equal to 10f. So we're going to draw a line with the axis line paint for the vertical y-axis, and we're also going to draw a line for the horizontal x-axis. So the start x is going to be 0, the start y is going to be height dot toFloat, because we want to start in the bottom left corner, and the stop x is going to be width dot toFloat, because we want to end in the bottom right corner, which is also height dot float for the stop y. Let's take a look and compile the app and see what it looks like. So as you can see on the emulator, we have a new axis line for each axis, which is drawn in red, just how we specified in the code. But you can see the data point is being drawn over the axis. Maybe that's not desired. Maybe we would rather have the axis be more important than the data point. The way that the way that objects are drawn on the canvas is in order of which you define them in the code. So you can see that we're drawing both axis lines first, and then in the data set, we're going through the data set and then drawing each circle, which means we're drawing the lines first, and then on top of that, we're drawing all the circles. If we took the draw line code and put that after, so if we're drawing all the circles for the data points first and then drawing the axis lines, if we run the code again, we should see that the axis lines are drawn on top of the data point circles. And you can see that happening here and here. So depending on what your needs are, you're going to want to draw things in a certain order. That being said, this could still be improved and made look more like a real graph. So a couple things that could be done is something like drawing a line to every data point in order, so that you can see like more of a line graph or a scatter plot. So I guess, yeah, more of a line plot than a scatter plot. So first, we're going to need a new line paint. So private val. We're going to call this data point line paint. Make a new paint object. Apply with the color is equal to color dot blue, and the stroke width is going to be equal to something like 7f. I'm kind of making these values up as I go, but you know, make them whatever you need to be for your project. So this, so for every data point, we're going to want to draw to the next data point. So I'm going to need to do a for each indexed on this data set, and the lambda parameters for that are index comma value. So now that we have the index, we're going to say if the index is less than dataset dot size -1, because we don't want to go out of bounds. Then we want to do next data point is going to equal dataset at index. It doesn't like the syntax. So I had this set as a mutable set of, and I really wanted a mutable list of with the same type. Now the difference between a set and a list is that a set is unordered in Kotlin, whereas a list is ordered. So, or indexed rather. So now that we can get the next data point out of the data set at a certain index, we can set up something like val real x or start x is equal to something, val index is equal to something, val start y is equal to something, and val end y is equal to something. So the reason why we need a start x and a start y and an end x and an end y is because we're creating a line from some point, which is 2 points, or from some point which is an x and y value pair to some x and y value pair. So we need 4 points overall to create a line. We're going to need to do the same logic that we did up here to create the real x and real y to convert the start x and start y and end x and xy for the current and next data point. So let's do something like create an extension function that can help us do that. So if we have a private fun with an integer as the recipient of the function, or the receiver, I believe it's called. So the integer is the receiver. We want to say convert or to real x. We'll call it to real x is going to equal this dot to float divided by x max is multiplied by width. And we're going to do the same thing for to real y divided by y max times by height. Now technically, oh, we need parentheses on here. My apologies. Technically, we don't need the keyword this, because this just refers to the receiver, and that's kind of just redundant in an extension function. So we can remove the word this, and now we have our extension function. So data point .xval, we can say to real x, and data point .yval, we can just say to real y. And that should work just like it did before. We could verify that by running the application again, and we should be able to see the application run just like it did before with new random values. Cool. So now we can dive back into the drawing the lines from data point to data point. So the start x is going to be the current point, which is data point, and we could actually just rename this as current point, or current data point. It's a little bit more explicit. So the start x is going to be the current data point xval to real x. The start y is going to be the current data point yval to real y. The end x is going to be the next data point xval to real x. And same thing for the y value, it's going to be next data point yval to real y. Now that we have all four of our points mapped from the xy value pair to a realistic xy value for the canvas relational point, we can actually draw the line. So we're going to say canvas dot draw line start x, start y, end x, and y, and give it the paint of, I believe we called it data point line paint. And we're going to do Control P just to verify that we got all those parameters right. Start x, start y, stop x, stop y, and paint. Perfect. So if we run this application again, we can see hopefully some lines drawn from each data point, and look at that, it looks beautiful. It's something that I would put into production immediately. Not really. I mean, there's a lot of improvements we can make to the visuals of this, and I'm not going to do all of them in this video. This is more of an introductory video towards drawing on the canvas, but for instance, a couple of improvements that we can make are, you can see the line that's drawn from each data point to each data point has a very rigid edge on the line. It looks like this was drawn in Microsoft Paint. One thing we can do to fix that is on the data point line paint, the line that's drawn between, the paint that's used to draw each line between each point, we can say anti-alias, or is anti-alias is equal to true. If we run the application again, you can see that while it's still a little bit rigid, it's a lot smoother than it was before and looks a lot better, definitely. Another thing that we can try and do to make the data points themselves stand out is maybe fill it in with a little bit of a white circle in the middle. So the data point paint, we have color is equal to blue. Maybe if we did a stroke width of 3F, maybe. I'm just kind of making up values as I go here, so bear with me a little bit. And we're going to do style is equal to paint.style.stroke. This means that when we draw with the data point paint object, that anything we draw will have a stroke width of 3, a color of blue, and it will only be the stroke. It will not fill the color. It will not fill the paint object. So that means if we run the application again, we should see an empty circle in the middle. And there we go. So you can see that there's a very thin circle. Maybe we made it too thin, but you can see that there's the intersecting lines in the center of the circle. So let's make this look a little bit better. Maybe this wants to be like something like 7F for the stroke width on the data point paint. Okay, it looks a little bit better. Now the main problem that we see now is that the circle isn't white in the middle, so it's kind of hard to see where the data point actually intersects. So the next thing to do would be to get the lines out of the center of that data point. The easiest way to do that is to create a new paint, and we'll call it data point fill paint. It will be the color white, and the stroke width doesn't matter. We won't be using that. The style will be paint.style.fill, which is the default value for paint, so we don't need it. Now the data point fill paint is just a color white. Maybe we'll make it gray. Let's make it gray just so we can kind of see what's going on. And the data point fill paint, we're going to paint just before we paint the circle for the data point paint, which is just the stroke. Now this means that we're going to draw a gray circle with a certain width, under a data point paint with a certain width that's just a stroke. So we should see a blue outline with a gray circle on top of where 2 points intersect. Let's run the application. Okay, so kind of interesting. You can kind of see that there's still a little bit of intersection on here, especially here. You can see that one of the lines is showing through and the other one is not. So let's take the draw circle commands and let's do them all the way after we draw all of the lines. So no matter what, our circles are going to be on top. Let's run the application again, and I think we should be good. Here we go. So here you can see the blue outline circles are on top of a gray circle, which are on top of the intersecting points of the line. So now this is starting to look more like a graph that's kind of a little bit easier to read. You know, maybe we change this gray back to white so it looks a little bit better. Now that we can see what's going on, and we change, you know, let's see what that looks like. Yeah, so that looks pretty decent. You know, maybe the data point is, instead of 10F, it's, you know, maybe something like 7F, and the stroke is something, you know, maybe still 7F, and maybe the main activity where we implement the graph view has a margin of 8 dp to, you know, set it off from the side of the screen a little bit. And with that, we get the red axis lines are 8 dp from the side of the screen, and you can see that the data point circles are a little bit more into scale with the data point views. And I think with that, I will end the tutorial here. There are so many things that I could go into on this custom view about how to customize this and how to customize that, but if you want to see more customized with this view, please do leave a comment in the YouTube video or a comment in the Medium article about what would you like to see customized about this view, and maybe I'll do a follow-up video on that if I get enough suggestions, because there are really so many things you could do with this view and so many ways you can make it look like your own and match your branding. So please let me know what you'd like to see next. If you have any suggestions on any of your favorite apps, so if you have a favorite app that you use all the time that has a really cool UX implementation or has custom views and animations and you don't know how to implement it into your own apps, please let me know, and I will try to cover that in the next video. Until next time, thanks for watching. Please like, subscribe, and comment. Thank you guys so much.